Today, we want to look at a new topic. We want to look at patterns, and they're going to be patterns of repeated operations. That's the first couple of patterns that we're going to look at. So I'm going to write down a list of numbers, and we want to try to determine what's going on in this list of numbers. So let's just say what's going on to make this list of numbers. We want to describe how things are changing in the list. So for example, let's suppose that I start off with 10, and then after 10, there's a 13. After 13, we go to 16. After 16, we go to 19. After 19, we go to 22, and then it goes on from there. We want to look for the different things that could be happening, and we go from 10 to 13. The first one we almost always pick out is we go from 10 to 13, that's an increase of 3. And then from 13 to 16, we've added another 3. From 16 to 19, we're adding 3. So it looks like in this list, in each step, we're adding 3. And so this looks like a pattern of adding 3 a bunch of times. So this list looks like we start with 10. So I'm going to just call out 10 as being somewhere we start. We start with 10 and then add 3 a bunch of times. And that's what's going on in this list. Let's suppose that we have a list where we start off with 10 again, but after 10 is 20. So maybe we're thinking, we add 10. But then after 20, I write 40. Now we didn't add 10 again. So it's not a pattern of repeated addition. And then after 40, we have a couple of candidates now, but then after 40, we say, plus it jumps up to 80, and then 160, and then it goes on from there. So in this case, we notice that we're not adding the same amount each time. To go from 10 to 20, and then from 20 to 40, and 40 to 80, it looks like the amount is doubling each time. So 10 to 20, instead of reading this as plus 10, we can read this as multiply by 2. And then from 20 to 40 is we're multiplying by 2. From 40 to 80, we're multiplying by 2. From 80 to 160, we multiplied by 2. So in this case, I started with the same amount. I started with 10. And then multiply by 2 a bunch of times. So there's a reason that I've listed these first two in this way. We add 3 a bunch of times, we multiply by 2 a bunch of times, because I want to prefer a pattern where I'm just doing the same thing over and over again. So I could look at this second pattern and say, well, from 10 to 20, we added 10, and then we added 20, and then we added 40, and then we added 80. And so we could figure out what's going to happen next. At this point, we should add 160, and then after that, we'll add 320. But here we're not describing it with one operation. Here we would say we start with 10, then add 10, then add 20, and so on. So if we can summarize our pattern with a repeated operation, then we will prefer that. So we prefer descriptions with a repeated operation. So we are going to prefer descriptions with the repeated operation. Because on our list of operations, we know that exponents is repeated multiplication and multiplication is repeated addition. We have operations that summarize repeated operations. So the reason that we'll prefer descriptions with repeated operations is that we have other operations that summarize those. Sometimes we don't get to summarize with a repeated operation. So let's suppose I start off with 10 and then we do 13. So it looks like the beginning, but that 2 is not enough to make a pattern. And then after that is an 18. And then after that is 25. And then after 25 is 34. Maybe this is what we're looking at. So in this case, we're not adding the same thing each time, and we're not multiplying the same thing each time. Well, let's check to see that we're not multiplying the same thing each time. So if I do 13 divided by 10, it's 1.3. And if I do 13 times 1.3, I don't get 18, I get 16.9. So I'm not multiplying the same thing. And if I look from, if I take 18 divided by 13, that means I'm multiplying by 1.38. And if I take 18 and multiply by the 1.38, I get 24.9, which is not the same as the 25. And similarly, 34 divided by 25, that was a little bit close. We're multiplying by 1.36. 25 times a 1.36 does not land up. Well, that will land us at 34. What did we not have? But 18 times 1.36 will not land us at 25. Did something backwards on that last one. So we're not multiplying the same thing and we're not adding the same thing. So we might still describe this as starting with 10, but we're adding, we start off, we added 3, and then we added 5, and then we added 7, and then we added 9. So we're not adding the same amount each time, but we notice a pattern in the amount that we're adding. So not adding the same amount each time. But the amount that we're adding is increasing by the same amount. Because from 3 to 5, we add 2. From 5 to 7, we add 2. And from 7 to 9, we add 2. But the amount we're adding is increasing by the same amount. So we want to look at a list of numbers, and we want to see if there are, if any patterns emerge. We want to see, and specifically, we're looking for patterns where we're adding the same amount or we're multiplying by the same amount. So we're looking at patterns of repeated addition and patterns of repeated multiplication. Patterns of repeated addition start with 10 and add 3 a bunch of times. Repeated addition. Or patterns of repeated multiplication. Start with 10 and multiply by 2 a bunch of times. These are the kinds of patterns that we want to look at. That third one is a quadratic pattern. where the repeated addition shows up one level down below our original addition. So we want to focus on ones where we could say add 3 a bunch of times or multiply by 2 a bunch of times. Even if our addition and multiplication is subtraction and division. So for example, if I look at a pattern that says starts with 10 and goes to 7 and then 4 and then 1 and then -2 and continues on from there. Repeated subtraction, we're subtracting 3. This is repeated subtraction. That's in the same category as repeated addition, because subtraction is just the inverse of addition. Subtraction is just addition of negative numbers or addition of opposites. So here we would say we start with 10 and subtract 3 a bunch of times. Or we could have a pattern of division. So I could start off, if I start off with 10, because that's what I'm starting off with today, apparently. I write a 5 and say, oh, well, are we subtracting 5 or are we dividing by 2? And the next one shows up as 2.5 and says, we're dividing by 2. After 2.5, we'll get a 1.25 and then a 0.625. So in this case, we're going to start with 10 and we're going to multiply by or divide by 2. So we start off with 10 and we divide by 2. 5 divided by 2 is 2.5. 2.5 divided by 2 is a 1.25, and 1.25 divided by 2 is the 0.625. So we start with 10. And divide by 2 a bunch of times. We can also phrase our dividing by 2 a bunch of times as multiplying by 1/2. We want to get used to saying things like that. We want to see that dividing by 2 is the same as multiplying by 1/2. Mostly because a lot of times we say we divide by half when we mean we divide by 2, or when we mean multiply by 1/2. So I always state them together so that we can make sure that dividing by 2 is the same as multiplying by 1/2. Because a lot of times, I don't know if it happens in other language, but in English we say cut it in half when we mean multiply by 1/2. So dividing by 2 is the same as multiplying by 1/2. Multiplying by 1/2. Multiply by 1/2. Multiply by 1/2. So in words, we might say we start at 10. Oops. And multiply by 1/2 a bunch of times. We just want to be able to describe patterns of repeated multiplication or repeated addition. We want to describe things that are happening a bunch of times. Any questions? All right, what we want to keep in mind is that we're picking repeated addition and repeated multiplication because we have operations that summarize those things. Remember that multiplication is repeated addition. So repeated addition is multiplication. It's like the multiplication summarizes our repeated addition. So if we're adding 3 a bunch of times, we're going to multiply 3 by some number. And then repeated multiplication is exponents. If we're going to multiply by 2 a bunch of times, we're going to multiply by 2 to some exponent, because the exponent says multiply by 2 this number of times. So we're going to summarize our repeated addition with multiplication. We're going to summarize our repeated multiplication with an exponent. Summarize repeated addition with multiplication. We're going to summarize repeated multiplication with exponents. So here are the patterns that we're looking for: patterns of repeated addition and repeated multiplication. We want to be able to describe a list as starting with some value and then adding a same amount a bunch of times, or start with a particular value and multiply by the same amount a bunch of times. And we want to find some kind of language that'll get us around saying a bunch of times, a bunch of times. All right. Here's the good news. Half of this we pretty much already know how to do. We know what's going on when we summarize a pattern of repeated addition with multiplication. We have done this before. Not we, because that would mean like me and y'all. We haven't really done that together. But y'all might have in a previous algebra class. Or y'all might not have. It's okay if you didn't. Here's what we're going to do. We're going to make a relationship between 2 variables, an input and an output. We need to quantify what we mean by a bunch of times. This business with a bunch of times is not very rigorous. It describes what's going on. That's the repeated addition, add 3 a bunch of times. But it doesn't really help us quantify things from an algebra standpoint. We understand the pattern, but we're not writing it in a very efficient way. So we need to quantify this a bunch of times business so we can encode it in math. So we want to be able to encode this stuff in algebra. So here's what we're going to do. I'm going to set up a we're going to use functions to describe the pattern. So we're going to set up a relationship between 2 variables. We're going to make a function with a pattern of repeated addition to start with. So we will make a function with a pattern of repeated addition. So I'm going to use two variables, one to count how often we're doing the thing, and one to be the actual variable. So I'm going to make a function with x and y. I'm going to say, let's start at 10. Just like before. And in the y, that's where the changes are going to happen. So I'm going to say, I'm going to go from 10, and then to 13, and then to 16, and then to 19, and then to 21. And 10 is going to be my start. So I'm going to say this is when x is 0. The start is when x equals 0. And then I'm just going to count the number of times we add 3. Notice that the pattern is still the same one I used from the previous page. We're adding 3 a bunch of times. And I'm just going to use another variable to count the number of times that we've added 3. When we go from 10 to 13, we've added 3 one time. And then from 13 to 16, we've added 3 to 10 2 times. And then 19 is adding 3 times. 21, we've added 3 22. Wow, did I do that on the previous page? Oh no, I had 22 on the previous page. I don't know why I was thinking 21. We've added 3 4 times. So I'm thinking of x as the number of times we've added 3. And so x is just going up by 1 step each time. So we described the pattern previously by saying start with 10, then add 3 a bunch of times. When we want to say, the way we would say to start with 10, we want to describe this as a relationship between y and x. So when I say start with 10, we'll say y is 10 when x is 0. So let's rephrase start with 10 in terms of x and y, and by saying that y is 10 when x is 0. And then the adding of 3 is something that's happening to the y. And then so we'll say, and add 3, and we'll say y increases by 3. And then we've got to say every step, and each of the steps is going to be 1 unit long because each step in x is 1. So a bunch of times is going to be every step. So we're going to rephrase a bunch of times as every step. And then we're going to notice that every step is 1 unit long. And so we're going to say y is increasing by 3 every 1 unit. Because each step is 1 unit long. So we're saying where y is starting off, we're saying what's happening to the y, and we're saying how often that happens. Where y starts, what's happening to the y, how often that happens. y is 10 when x is 0. Y is increasing by 3 every 1 unit. We're describing where y starts. And then we're describing what's happening to the y. And then we're describing how often that happens. So this is how we're going to start writing equations for patterns of repeated addition. We want to say where y starts, what's happening to y, and then how often that happens. Let's look at another example where we're going to describe where y starts in this fashion, y equals 10 when x equals 0. We're going to describe what's happening to the y. Y is increasing by 3, and then we're going to say how often that happens. So let's make a function. Let's say y is going to start at 23. So this part says y equals 23 when x equals 0. Because I'm describing that point, a starting point. It's taking a value of y and a value of x and tying them together. That's where y starts. Then let's make a thing happen to y. Let's say after 23, we go to 19, and then we go to 15, and then we go to 11, and then we go to 7. And let's say this happens every step. So what we notice is that from 23 to 19, we subtract 4. From 19 to 15, we subtract 4. From 15 to 11, we subtract 4. From 11 to 7, we subtract 4. It looks like y is decreasing by 4. So y is 23 when x is 0, and y is decreasing by 4. And we are describing what's going on. And then we look at how big the steps are. This is going to happen every step, and each step is 1 unit long. This is 1 unit each of these steps. So we'll say decreasing by 4 every 1 unit. So here's a sentence describing what's going on in this pattern. Y is 23 when x is 0, and y is decreasing by 4 every 1 unit. That's how we could describe what's going on in this pattern in words. I want to do one more example. And I'm going to change the step size. So let's change the step size. Let's write a relationship between x and y. I'm going to go, I'm going to start at the same place, 0 and 23. And I'm going to use the same decrease. Otherwise, I'd have to subtract a different set of numbers, and I don't think I'd be able to do it. But instead of the step size being 1 unit long, I'm going to count the x's by 3s. So it's going to be 3, 6, 9, and 12. So what's happening in the y is still decreasing by 4. but now I've changed the step size. So each step is 3 units long. That's the adjustment we've made in this pattern. So our description would say y equals 23 when x equals 0. We're tying the 23 and the 0 together as 1 point. Let's describe what happens to the y. We'll say y is decreasing by 4. And then we'll say how often that's happening. Every 3 units. Y is 23 when x is 0, and y is decreasing by 4 every 3 units. We're describing where y starts, we describe what's happening to the y, and we describe how often that happens. Any questions? Once we describe this pattern, we can read this in, we want to be able to read this in algebra. We want to be able to encode it in algebra. We've taken the numbers and we've written a sentence describing what's going on, but we need an algebra sentence that says the same thing. So we'll say something like y equals 23 minus 4 over 3 times x. So we'll have essentially y equals mx plus b, where m is the rise over the run. Slope is rise over run, and we have a y-intercept. That's what we're trying to do when we were trying to program you with y equals mx plus b. We picked a terrible order. We, like I was there. Instead of saying b plus mx, where it says start with b and add m a bunch of times, we decided to go add m a bunch of times to b, which is just really weird and backwards way of saying it. I think it's because these linear functions probably, the way we describe them in algebra did not originate in English. And so the translation kind of came out backwards. But like I said at the beginning, you're familiar with half of the stuff that we're doing. I just want to put more thinking around what's going on. I want you to be able to describe where things start, what's happening to the y, how often that happens. Y-intercept, just any starting point really. Rise and run. Rise is what happens to the y, run is how often that happens. The reason that I want to break it down into these three things, these 3 pieces of the description, is that I want to change decreasing by 4 to multiply by 4, or multiply by a half. And I want to be able to start off at 23 and multiply by a half every 3 units, and be able to easily write an equation that expresses the same thing. So tomorrow, we're going to practice writing more sentences, and then we're going to practice writing the equation that goes along with the sentence. That's going to do it for today. That's our introduction to starting to read patterns of repeated addition and repeated multiplication. Everybody have a good day, and I will see you on tomorrow.